Hey, Topic Analyze the Math Industry, and we are going to take a look at the exterior angle inequality theorem. So we are back in the geometry unit after doing the economics unit. And in this part of the unit, we're not going to do a lot of theorems, and we're not going to do a lot of proofs, which means that we're not going to say given reason and deduct our way to get to an answer. What we're going to focus on is trying to understand the dimensions of a shape, like a triangle. And what we're going to do is we're going to learn and understand the different tips and tricks about it. So here's the first one. Exterior angle inequality theorem. But hang on. What does that even mean? So, do you remember that triangle that I showed you earlier in this video? Well, you see how this triangle has 1, 2, 3 sides? Imagine if I make one of the sides a lot longer. Something like this. But hang on. If you're ever asking, why does this have to do with exterior angle inequality theorem? Well, it talks about the different angles of this figure right here shown. Because, here's the definition. A measure of exterior angles of a triangle is greater than the measurement of a non-adjacent called remote exterior angles. That's a lot of information, but exterior angle. What is that? So, when you hear the word exterior, you might think something outside of something. And technically it is. So we're going to say that these angles right here are going to be interior, because they're inside, literally inside the triangle. Exterior angles would be those stuff outside the triangle. This giant angle would be the exterior angle right there. And the theorem is literally saying the measure of exterior angles, this one, of a triangle, is greater than the measurement of non-adjacent angles, or called interior angles. What they're talking about, or what we're talking about, is that this figure, this angle, has to be a lot bigger than these. So let's try something out. We're gonna put numbers into them. So, if you're trying to find something like this in real life, a flag with a triangle on it can be an example. Well, this is the pole. So you notice that we put an X right there, and another 32 right there. A number 32. The thing is, we gotta find out what can X be, but also follow this theorem right there, and also apply it with 32 degrees. We have to come up with an inequality, because X could be anything, however, it must follow this rule. So what we're going to do is put X in the middle of the equation. And we are going to say that X is going to have to be greater than something, however, has to be less than something as well. If we put stuff in here, and it's all true, then X can be anything in between these two boundaries. So, it already says that the exterior angle has to be greater measurement than the non-adjacent interior angles. So we're going to say that 32 goes on the top to the left. So x has to be greater than 32 degrees. But what about the other one? What about this one? So it talks about x right there as an exterior angle. X could be anything until it no longer becomes an angle. 180 degrees. Since this is an obtuse angle, and it has to be greater than 32, it can be any angle until it doesn't become one, which is 180, which is a straight line down. So here is what x can be. Anything that's greater than 32, or can be less than 180 degrees. Let's do one more example. However, about this one and the last one, we have an input for the obtuse angle, or the exterior angle. The thing is, x is inside and is one of the interior angles. Wait, so how do we do this one? Well, it does say that x is going to be less than 108 because it's an interior angle. So what we're going to do is put 108 right there. But wait a minute. What about for this one right here? Well, that last one when we talked about when you have the measurement for the interior angles, it has to be greater than these two. But it could be anything until it no longer becomes an angle. And that applies to this one too. So, x being less than 108, but it has to be greater than 0. That means your letter x could be like 1/10 of a degree. If it's 0, then there is no degrees, because it's still like a straight line. If it's like 0.111, then it is a degree. So, looks like we found our inequality for this one too. And not only that, you guys earned your degree on this video for exterior angle inequality theorems. I hope this video has helped you understand exterior angle inequality theorem. Thank you for watching Top Penalized Math Industry. Like and subscribe.